What I want to do is just, like I said, a couple out of each one of these sections and just kind of show you guys how some of these tricks are working. For example, if I just start out with 27. There's two ways you can get them and do this. If I'm looking at that, I have different bases with the same exponent. It's a fraction. You agree? Which means you're dividing. Which means this is the same thing as that. Do you agree? Now, for those people that have been gone for a lot, maybe writing this down would be beneficial instead of sitting there. So, can you simplify that fraction? What do you get?
5.
Do you do anything else? And that's where we do. To be honest with you, that's kind of what you do. With the idea here is, and I think I mentioned this when we talked about this the first time, if the problem starts out with a fractional exponent, you end in a fractional exponent. If it starts as an nth root, leave it as an nth root. It's kind of just the etiquette way of doing things. All right. It's one nice clean way of doing it. Yes, sir.
Is it okay if you just put 70 over 14 as like C, so instead of 1?
Means the same thing to me. It means the exact same thing to me. It's not a problem. Yes, ma'am. The etiquette, I'm trying to get you into the etiquette. So just remember it. Okay. Now, also within that first grouping, you had, let's see here, something like this. Same basic idea, isn't it? You have a whole bunch of different bases, but you have the same exponent. So the easy thing to do here is just rewrite it as one giant fraction. And simplify it. Get 8 to the 2/3, which is the cube root of 8 squared.
Oh, good.
All right? And I will tell you this right now, guys. You have to be able to do this without a calculator. You will not be able to use a calculator for these things.
Can we use the dumb calculator?
No. You will not be able to use a calculator for this. All right? Because there's a square root button, there's a power button, there's an extra button. Your answer is 4. Because what's the cube root of 8?
2.
2. 2 squared is?
4.
4. Yeah, and sometimes if this happened to be like 7, you couldn't go any further. But what you need to start recognizing is, what does that mean? It means a cube root. You need to know your cube roots through 6 is probably 216, 125, 64, and then 27, things like that. All right. The very basic ones, and that's kind of what we show a lot of. All right. There are other ways to do that one. I think that's the easiest. Some people have been asking about this a lot. Same base, different exponents in your dividing. What do you do with the exponents?
Subtract them.
Subtract them. You play war, or isn't this just a negative exponent?
Yeah.
He's not happy, is he?
So you have to put them on top.
Wouldn't you be doing that anyway? Because it would be this minus that.
Yeah. Yeah.
Same base, different exponent, and you're multiplying. What do you do with the exponents? You add them. You want to?
That's why you got that wrong.
Final answer. Because it started with the fraction, you ended in a fraction.
Oh, you got that right?
No. No. Okay. See how easy that is?
Yeah.
A lot of times, some of these things you guys wanted to overthink. Speaking of overthinking, that's what happens when you get into some of the ones that are nth roots. Now, there are a bunch of different ways to do these problems. I'm going to show you a couple. First one should be relatively simple, because what's the square root of 64?
8.
What's the cube root of 64?
2 or 4. I meant 4.
What's 8 times 4?
32.
Now, Another way you can go about that is to simplify it when they have the same base. I'm going to rewrite both of these as fractional exponents. Is that okay? Those are same base, different exponents, right? What do you do to the exponents? You add them. So it's 3/6 over 2/6. So you 5/6.
Oh, okay.
Which means what's the 6th root of 64 to the 5th power?
Yeah.
32 is 2 to the 5th power times 2 is, so what's 64, the 6th root of 64? 2. And 2 to the 5th is? It's another way of doing it. Yes, sir.
How do you get 5/6 together?
1/2 plus 1/3. 1/2 plus 1/3 are fractions, so it's 3 over 6 and 2 over 6. All right. It's another way of doing it. Do you have to go that route? No. But I will say when we get into values that are more variable based, it's easier to work with exponents. There's more than one. Okay. You do basically the same idea on the other one. On the next one, you have same nth root here, correct? Which means I just multiply them together. So what's the 4th root of 16?
2 and negative 2, right?
We only worry about plus minuses if we're doing equal signs here. We're not doing any equal signs here.
Like only for solving for variables.
Yeah.
We only worry about plus minus if we're finding a variable.
You only worry about plus minus when you're doing the square root over equal sign. You're taking the square root of both sides. Okay. Does that make sense? Okay. Now, as you get into some of the more complex ones, like 38,
Ooh, I have that one.
when you have 38, does everybody agree you have the same base?
Yeah.
It's just now written as an nth root. So let's rewrite these bases with an exponent. Isn't that 7 to the 1/2?
Yeah.
7 to the 1/5. Who wins in the game of war?
The half.
What's 1/2 minus 1/5?
Is 3
5 tenths and 2
3
tenths.
tenths.
So it's 7 to the 3 tenths. All right.
Oh, and that's why I
You're
got that.
doing the exact same thing as you used to do, but it's just with a fraction as opposed to an integer. Okay? So hopefully it isn't as scary as what you guys are going.
No, it's just like sometimes you like saying
You overthink it. Okay? You guys tend to overthink. A lot of things.
I've been told I need to stop.
What?
I don't know.
By which one? Crabby? Or, yeah.
He's off to like after.
Wait, I thought, okay, did he have something going on with his students or
There's
this?
our rumor.
There's really.
Oh, I've heard a lot of different things then.
So why is he gone?
So that's what these are pages. So like there's so many rumors in the like something like that. It's a lot. Just hear
When he was like accused.
Sorry.
of it, but
Little inside
it
joke.
wasn't proven.
In this one, do you all agree that the numerators can be multiplied together and denominator can be multiplied together?
Yeah.
Okay. So I get cube root of 54, the 6th root of 4. No?
Oh,
Yeah. So now your goal here is you want to try to get them into the same base.
Oh,
If I'm looking at the cube root of 54, I can simplify that. Because what's the perfect cube that goes into 54?
8.
27.
Oh, wait. I don't know why I said 8.
That's the cube root of 27 times the cube root 2.
Okay.
Okay on that? Now, down here, I'm going to rewrite this as 4 to the 1/6. You okay with that?
Like here, I did that first part right, and then I just like didn't even think about writing 4 to 1/6. So then I ended up like multiplying it by.
Because what can you rewrite 4 as?
Well, no, I understand. It's just like the first thing that came to my mind is just to multiply it by the denominator.
Yeah.
The denominator times 1.
Oh, yeah. No, this one, it works a little bit cleaner. Yes, sir?
Could you just factor and multiply all the like terms too?
No, you got to have same exponents.
Oh, sorry.
Okay, we don't have that yet to be able to do any of that. Can I rewrite 4 as 2 squared?
Yeah. Wait, and then, oh, and then you do to the second. Oh, this is-
Now, 2 squared to the 6th, isn't that 2 to the 1/3?
Sure,
Yeah.
yeah.
Because it's 2 to the 2/6. And that's the idea here, guys. You have to start looking into the problems more and more to start looking at the very basic base. All right? And the reason I'm trying to get you guys to start looking at these bases, to get them to their most simplistic form, is because it's going to help you so much more when we get to logarithms. When we get to logarithms, it's all about bases and exponents. So now using my exponent rules, power to power, I'd multiply that. I get 2 to the 2/6, which is 2 to the 1/3, which is the cube root of 2.
Oh my gosh. And then you just get, so you.
Not cross multiply, but they simplify.
Yeah, that's nice.
All
Wait.
right.
So
So now the cube root of 2 divided by the cube root of 2 is 1.
So you would just get to reiterate?
Yep.
Oh my gosh. So simple yet so complex.
And it takes time. All right? It takes a little bit of time to get. You took you time to start to think about how to simplify radicals. Now we're just working with nth roots. Sir.
I know it's a little like the beginning, but do you have any idea of when like the first test or quiz will be?
It will, like I wanted to do it earlier than later, but I was looking at my notes from last year and I quizzed it after section 4. And I don't think that would be a bad thing. So I don't know where that's going to sit Wednesday at the earliest, because the next 2 sections, after today, the next 2 sections are kind of the same. So it gives us a little bit of time. But
Also, is this like preparing us for?
what?
Is this like preparing us for?
Yeah, a lot of this, not so much this part, but how we switch things into their lower bases, how you can rewrite things in terms of bases. It really is prepping for logs. Let's see. Now, why you have to do what you do. When we talk about rationalizing the denominator, that means you don't want any radical in the denominator. Do you agree? So what I want to do real fast is just go back to the old-fashioned 3 divided by the square root of 5. You got to get rid of that root 5 in the denominator. What would you do? Multiply root 5 over root 5. Square root of junk times the square root of junk is junk. Now, what I want to show you here is what you're doing exponentially. This is 3 over 5 to the 1/2. This is 5 to the first power, isn't it? Notice how in the underneath the radical there is the same base. They're both 5s. What's the exponent for both of these bases?
1/2.
So 5 to the half times 5 to the half equals 5 to 1, right?
Yeah.
You're creating power of 1 in the denominator. That's how you rationalize. So if you go back and think about, well, this can be split up as the cube root of 1 over the cube root of 7. What's the cube root of 1?
1.
Now, I'm going to rewrite this as a fraction. Cube root is what power?
3rd.
Third power, good. So I have 7 to the 3rd, and I know I need to multiply it by something to make it 7 to the 1st How many more thirds do you need to make a whole?
2/3.
You multiply top and bottom by 7 to the 2/3. You're filling in the fractional amount to create the whole. Does that make more sense?
Yeah.
Oh, so it'll end up
And
being,
we
okay.
have the same thing.
And this here, 7 and 2/3, or 7 to the 2/3, and 7 raised to the 2/3, divided out, it's just a factor of 1, right? So all you're doing is multiplying it by some shape of 1. It's not changing anything, it's just making it look weird. It's like putting lipstick on a pig. It's a good analogy.
We might be able to argue about now.
Oh yeah, how'd that work out for you?
I won.
Nice.
Good story.
So your numerator has just become 7 to the 2/3, but once again, notice how the problem started. You read it as, so it'll be the third root of 7, quantity squared, all over 7. You always rewrite it, because if they give it to you in terms of nth root, rewrite it as nth root.
Wait, so you don't want us to, I thought they had the same base, is like 7 to the negative 1. If you have to have the same base, you just subtract.
If you do that, who would win?
No one, I guess the bottom.
The bottom would win, and wouldn't you wind up with you'd have a negative exponent then, wouldn't you? This alleviates,
We're not allowed to do that.
right. What this is doing is, you're right, but you wind back up here. You see how that goes?
You have to put it back up.
Yeah.
Oh, all right.
So you wind up with it, you wind up in that infinite loop. If you ever take a programming class, the infinite loop is the worst thing that could ever happen. What's happening here is we're rewriting all of our exponents to have positive values. That's what that means. When it says write all your exponents in terms of positives, that's what we're doing. Okay? Not as scary as it looked, is it?
No, it's.
All right.
All the ones that
All right. So in this one here, I wind up with fourth root of 80, fourth root of 9. 9 can be rewritten as what?
Oh, for 3 squared.
3 squared.
Oh, I get it.
Now, I don't know if this is going to help us do anything, because then we'd have to figure out to simplify out the 80. So let's put this on the back for right now, just in case we might need to. On the back burner, sure. So this is the same thing as saying 80 to the 4th, 9 to the 4th. You okay on that? Oh yeah, that does work. I forgot about the 16. Yeah, I'll go back that way too.
You get the same.
You will. I mean, I'll go the long way, then I'll come back to the shortcut. So here, what do I have to multiply top and bottom by?
9 to the, oh, you're right. I keep on. Oh, darn it. Just kidding.
And now you'll notice that you can't do anything because you don't have the same base. See that? You have an 80 and a 9. They're not the same.
Yeah.
So in essence, the whole idea of going back to this to begin with, well, that should be a good idea to do. Let's see if we can simplify that. I know I can't divide 80 by 9. I know they're not divisible by 3. I know 80 is not divisible by 3. So what I'm going to do is rewrite it in terms of a lower base. So let's move this out of the way. We know that it equals that. And if I rewrite that fractionally, what do I get? Sorry, I wrote that incorrectly. Isn't that 3 to the 2/4?
Yeah,
Which is
1/2.
1/2. So you get 3 to the half there. We okay on that?
That's not the whole problem.
That's not the whole problem. Let's just do the 9. I'm just working with the 9. I'm just working with the 9 right now. So now, you were saying earlier that 16 goes into 80 how many times? 5 times, right? So that's the same thing up here, saying the 4th root of 16 times the 4th root of 5. You okay on that? All right. So now, what's the 4th root of 16? 2. So we have 2 4th root of 5 by 3, which basically works out being the square root of 3. Oh, that is good. All right. That is ugly beyond ugly. Because, well, you still got a root in the denominator, right?
So we have to.
Yeah, but now we wind up with multiple roots in the numerator, which is okay. Because you can't really do anything with that, can you? But if I do this, the denominator becomes okay. Do you agree?
Yes.
So would that just be 2? It's one of those etiquette things. Etiquette, schmetiquette, right. So you wind up with something like that. And I believe that's exactly where they leave it. So I don't think they changed up from that. Yes, ma'am?
Why did the one down in the left corner now not work out?
Why did one of them?
The fraction.
In order to combine those terms, multiply the 80 to the 4th times 9 to the 3/4, you have to have the same base. We only have that. Is 9 the only common base that I can get would be 3 and 1. 80 is 1, 2, 4, a lot more. Maybe some more.
So it just wouldn't be able to look that way? So we'd have to go the other way?
Now, S just
It's the
ugly.
same as the square.
Okay.
Oh.
It's up. Yeah, it's just, yeah, square root is assumed that's a 2 value that's alpha. It's just always there. So that's just an ugly problem.
Yeah, it made me kind of sad.
No, I'm sorry. 49 is a little happier though.
Is that? Yeah.
Notice how 4 and 8 can both be rewritten in terms of base 2. You okay with that?
Yeah.
So can I rewrite that numerator as 2 to the 2/3? We okay with that? Just jumping right to that?
Yeah.
2
Squared.
It would be the cubic root of 2 squared.
Correct. We are with that?
Yeah.
Denominator would be 2 to the 3/5. Yeah, now you have the same base with different exponents. You gotta play the game of war.
15.
So I don't know who's win between 2/3 and 3/5, but I can convert it to a common denominator of 15 and look at it that way. 2/3, it would be 15, 10 over 15, and then this would be 15, 9 over 15. So who wins? What's 10 minus 9? 15th root of 2. All right. Notice again how we're setting this thing up. We're trying to break it down to a common base. Work with our exponent rules, because once you start working with exponent rules, there's not that much going on there. Okay. Good play war. When you get into working with the next grouping then, think of it in terms of combining like terms. What's 3x squared plus 2x? What is it? It's that, right? It's 3x squared plus 2x. I can't combine anything because they have the same base, same exponent, all right? Now what is it? 5x squared, okay. Aren't these the same base, same exponent, same base, same exponent?
Yeah.
So it's just 6.
6,
5
5,
and
6, 5, 6. Oh,
said
that's
that
not one. I always say
Same
one.
thing.
That's right.
Exact same stinking thing.
Oh, I did get that.
Okay.
53, that looks simple, but I don't know.
It looks simple because think about what it's asking you. It's what's the square root of 160 minus the square root of 10. Well, you can't do that, can you? You got to get the same base. Well, the second one is root 10. There's no perfect square that goes into root 10, right?
Yeah.
So you're probably going to have a perfect root in the other one.
16. I didn't get that.
160 simplifies out to be 16 times 10, right?
Yeah.
What's the square root of 16?
4. 4 root.
Wow.
4 root 10. Oh,
4 root 10 minus a root 10 is how much?
Root.
3 root 10.
This is so nice.
Man, that's such a nice feeling.
It worked.
Is it a very good feeling?
Did I say it wrong?
No.
Yeah. It's a very
Is it feeling you know that I'll be back when the day is due and I'll have some more ideas for you. And you'll have things you'll want to talk about and I will too.
You know, usually we sing when you say
I
something.
can't believe I do that. Always back.
What song is that?
What, I know I've missed you. I still hate you, but it's all right. The picture, did you see the picture?
No, she didn't.
You haven't seen the picture? I'll show you the picture. The picture's awesome.
It's a picture of me and Facebook Live. Aww.
That's so cute.
Did you just change that, or have we never seen it before?
No, I've had it like that for a
So we've never seen it before.
Yeah.
I think I've seen it once.
there's some
It changes
animals
this
on
like
there.
every week and it's so cute.
I don't know if I downloaded it or not. I just have my flip. I'll show you. I'll show you after this. All right. Okay.
Harley pick. That was so weird.
That is weird. I don't even remember.
Me and boys at Harley.
Yeah, we.
Me and
Yeah, they sat on Santa's lap at the Harley.
Oh, I thought you meant like me and like your friends. Like I'm like me and my
Me and the
boys.
boys.
Yes.
Yeah.
Wow.
Hold up, hold up.
So look at these two. Same basic idea here, guys. You have to be able to try and get them into a common base. So you want to try to simplify them through. If I'm looking at 54, I got the cube root of 375 and the cube root of 81. I know I could probably figure out the cube root of 81 a little bit easier. Cube root of 81 81 is 3 to the 4th power. Do you agree?
Yeah.
So what's 3 to the 3rd power?
27.
So this is the cube root 27 times the cube root of 3.
Yes.
All right? Over here, if I'm looking at it, 125, isn't it? So it's the cube root of 125 times the cube root of 3.
Wow, that's crazy.
It is crazy. Remember how we did this with the square roots? Once you figured out one of them, the other one, if you could divide it by 3, you should be able to figure it out right away. So now you have 5 cube root 3 plus 3 cube root 3, otherwise known as
8 cube root 3.
Oh gosh, I'm lost. Wait.
Huh?
Wait. 5. Where did all that?
it's cube root of 125.
Oh, 5.
There you go. All right, so you get 8 cube root 3.
Wait.
54.
On the other one, what do you think you're going to have to divide the 176 by?
3.
3.
Oh, I got it.
Look at the cube.
It's
What's-
4. Oh, 55.
It's 14 times 11.
It's 16 and 11 because you're left with the 4th root of 11, which you can't do diddly-do with. So what can you take out? What's the 4th root of 16? I'm sorry.
2.
Yeah.
Yeah, 16. The 4th root of 16 is what?
2.
What's 2 times 2?
4.
What's 4 plus 5?
6. 9.
I'm blowing you.
Everyone got 6 because I said 6.
Because everybody wants to be like you.
Yes, exactly.
Okay? You're looking for those perfect squares. You're looking for perfect cubes, fourths, things like that. When you have something you can't simplify, try to divide it into here to get you into that. That's all. Here, this is the fourth root of 16 times the fourth root of 11. Fourth root of 16 is 2. 2 times 2 is 4. That's where we're going with that. All right. So as you go through these, hopefully now it is not as large of a scuttlebutt as it might have been earlier in the week.
Okay.
Making stuff up.
No, it's only a plus.
Are we gonna turn this in? Or is it?
No,
just
we got more to do. We haven't done the other stuff yet with variables yet, have we?
Was that a sign?
Because
No.
you're going to do better at variables.
Now I'm here to do plus one.
I hope so.
No, are you taking squares over equal signs?
No.
Okay. You don't have to worry about those absolute
Oh,
values
still-
because everything's. Yeah, you want to make. Yes, sir. Yes, ma'am.
Can I just give you like all the ones that I missed on Monday?
It's fine.
Like, all-
So when we're looking at stuff like this, it works out to be, like I said, it's actually easier. So let me just jump right here and do 65.
So are we just doing this for practice?
No, because we're going to do homework still. I'm just going to show you this. We're still in the same section. We just didn't get this far. So I'm going to simplify that.
So
It's fine.
where should we put this? On our homework?
Homework notes, wherever you want to do, because I'm not. You're going to add to your homework.
Again?
Oh yeah, it's just, we're not done with this section yet.
That's not happening.
There's a lot of
Boy. That's crazy.
So let's see here.
Ooh, I think you got it. Whoa. Why are those?
When we have all these things here,
Oh, wait.
go variable by variable by variable. Go variable by variable. You have x to the 3/4 over x to the 1/4.
X is the 2/4 on top.
X to the 2/4 up top. Everybody okay with that? What's x to the 2/4?
1/2.
X square root of x.
But they wrote it in terms of fractions, so you leave it in fractions, okay? So now you have y.
Y. And then z.
So z to the negative 1/3 over z to the 2/3.
It's Z on the bottom.
It's just
Z.
Z because it's Z to the power of 1.
Yeah, because it's
Wow.
Z and 2/3 plus 1.
Let's go.
You
See?
made me smile.
Variables are easier, okay? Variables are easier to deal with. Do you remember how we did this?
Yeah.
Well, so,
Yeah, you have to like pull it out.
And then.
like, how
So
many
when
times
you
that
end
goes
with
into
X
that?
and then you put Y.
Do you remember why it works?
It's like
No.
longer.
No.
Nah.
I think the bell was like about to ring. I was trying to listen, but I was like,
Sorry, my life would be what?
How you like that?
Notice how you have a negative exponent, so he's not happy. Bring him down, so it's z to the 2/3 times z to the 1/3. Add your exponents together. Does that make sense? Now in here, I'm going to show you real fast why that shortcut worked that we did the other day. Does everybody agree that I can rewrite all of this as 10 to the 4th, x to the 5th, to the 4th, y to the 8th, to the 4th, z to the 10th, to the 4th. Everybody okay with that? Are you okay that I can?
Is it because normally you know how it's like root x, fifth root x to the 4th, but is it just x to the 5th because it's under a radical? Like, you know
Means
how
the same thing, yeah.
How we normally take
Yeah.
it apart like that as the radical references is
It's the same thing because you just slammed it all together. Now, does this becomes 5/4, right?
Yes. Because of it.
Yes.
Yes. Oh wow. Gee, guys.
get it right. Two, and that's
Which is what is that? 2
5 over
2.
5 over 2. All right.
okay, you make sure you got your pen.
So then you just get,
So here's why this worked then. So can you get the 4th root of 10?
No.
So it had to stand underneath the radical. 4 goes into 5 how many times?
one.
There's one whole, and how many are left over?
One.
1.
5/4. There's one whole and a fourth. So there's 1 and 1/4.
Oh, I got it.
How many times does 4 go into 8?
Twice.
So you just get y squared.
There you go, y squared.
And then.
Hold on. And then 4 goes into 10 how many times?
Twice.
How many are left over?
So two. So it'd be two.
And here's why. Again, look at your fractions. It's when you simplify it out in long form, it's x to the 5/4. 1 and 1/4. 1 came out, 1/4 stayed in. 8 to the 1/4 is 8 over 4. 8 divided by 4 is 2. 2 came out, nothing left. 10 over 4 is 5/2. 2 come out, 2 stay in.
Why do that one confuse me?
Okay, you have to, don't do it with the simplified version,
Oh, do
because
it.
it's 1/2, you keep it to the 4th root, so it's 10 over 4. 4 goes into 10 twice, with 2 left over.
Oh.
That's fine. Yes, sir?
So, for x,
Wait,
y,
Wait, why is there?
with one left over.
It does.
We were saying 10.
Yeah, I was talking about that.
Wait, why are there? Oh, that's a.
Yeah, 1 came out, 1 stayed in.
No. Oh, is that an X or
I thought it was a
I
Y.
thought that was a Y.
Sorry.
I wrote
It's
it
an
down.
X, guys.
Jeez Louise.
I mean, if you were watching him while he did the problem, you know it was an X.
Well, I was trying to write because he's standing in front of the board, so I can't even watch him.
Throwing shade. Throwing what?
It's like sneaking.
I did too. Oh, there we go.
Oh, really?
That's what you
There
should
is an X, you just wrote XX.
Bruh. Bruh. Can you make it like a different color? That's embarrassing.
for y, 2, 4 goes into 8 2 times.
So 2 come out, no left over.
Okay, so the things that.
I'll show you how.
Swerve.
Okay, I got it. I think I got it. I hope I got it.
Swerve. Swerve.
Oh, that's easy.
I can rewrite this as a giant 5th root. 48 x to the 7th, y to the 7th.
Yeah.
5th root of 48. Well, remember, the 5th root, the easiest one to know is 2. So 32 doesn't go into 48, does it?
No.
So there's no perfect 5th root that goes
So
into.
then you do the 5 goes into 48.
So the 48 stays under. 5 goes into 7 how many times?
Once.
Which is it?
Once.
How many are left over?
2.
Now this is going to be an x. And then on the inside it's going to be
Wait, why?
1 came out, 2 left. 2 are left.
2 left over goes.
So wouldn't it be? Wait,
Yeah, because
5
this
goes
is the
into
same as, that's the same as saying
5
x to the
goes
2
into 7
fifths.
once.
And how
Oh,
many
and
are
then you do the 2. Sorry.
5 goes into 7 how many times?
Once.
1 comes out,
2 stay in.
2 stay in.
Oh, so since it's 48, you just. Oh, sorry, 48.
When you're looking at 5th root, it's a smaller digit, it's 32, and it doesn't work. Okay? You're going to find out that working with variables is a lot easier than numbers.
Yeah, I like
happy
swerve.
We'll get to the packet. I'm not worried about that right now.
Clear.
But I do want you to do, what is this, page 412? This is still 7-2, page 412. I want you to do 56 through, what number was that?
12.
90, the
The
evens.
Are we gonna end up doing the odds?
No, we won't have time to do all the odds. All right, you will find out that working with the variables is, 3 times as fast as working with the numbers. All right, you will be pleasantly surprised at how easy it goes. All right, give those a shot over the weekend. Monday we'll jump into working with function notation again. We're gonna do composites, f of g, g of f, things like that, and then we'll do some inverses Tuesday. Sounds about right, yeah. Inverses are pretty easy. But you have to do a lot of explanatory rules, that's why I want to make sure we get these things down. All right?